This is the drag. I'm Krish Patel, and I'll be going through this presentation here for Lab 2. So the main purpose of the lab, to kind of introduce it, is to differentiate the results and compare and contrast a computational versus observational model. Additionally, to compare the results from the computational model with and without the force of drag. The main setup here, a paper plate will be dropped from a height of 1 meter. The plate mass is 9.3 grams. And the software used for this experiment will be Tracker and Glowscript. The fundamental physics principle here is Newton's second law, as we'll be incorporating several different forces as well as mainly the force of drag that we're kind of comparing with this experiment here. Mechanism of examination. So as mentioned, there will be a paper plate that will be dropped from a height of 1 meter. A video of this plate dropped will be captured via an iPhone 14 camera. It'll then be uploaded into the tracker software and analyzed using coordinates and point of mass to develop a graph and table for the computerized data that we'll do later. This will develop here the observational model. Position and velocity vectors can be derived from that observational model through the graph and table collected as mentioned. From there, Glowscript will be utilized with the starter code to develop a computational model. Another computational model will be developed incorporating the function of drag. So here's just a quick little image of the observation part of this experiment. You can see the paper plate there dropped from roughly a height of 1 meter, this is the video file that will be then translated into the tracker software to be further analyzed. So here's the developed observational table and graph. So it was an overtime of 0.367 seconds, and from the X and Y column you can see the different positions that it was at a certain time. Now this was used to develop the position and velocity vectors that will then be put into Glowscript, which is then used to develop that computational model with and without drag, which is the point of the experiment to kind of compare those two. So here's a quick image of the initial computerized model that was developed. You can see the starting point. The ball is representative of the plate. One error to kind of focus on here is I was not able to find something representative of the plate to put in for my graph, so the ball will have to be representative of the plate dropping. Continuing the initial computerized model, the first graph showed the position versus time. And the velocity versus time of the translated based on the new position vectors, velocity vectors, and the starter code that was morphed kind of to be representative of my observational model, which resulted in these two graphs as well as the prior image that was shown. Now here's adding that force of drag. In starter code you'll see it's a line of FD, that it stands for force of drag, which will then be used to develop that force in the code, which can be then taken in here. Now you can see here that from comparison of the two, you can see there's a very, very minor change in the position versus time slope, but it's hard to differentiate even via computation. But you can see all three data that was collected with the addition of the force of drag. What can we derive? The position of the time versus time for the computational model has a more curved appearance, while the observational model has a more linear appearance, is one thing that I saw. Further analysis, there's very minimal to no observed change between the computational model with drag and the one without from my experimentation. My initial hypothesis here was that the force of drag will develop a model that has lower slope. That's unsupportable. Errors. Now, one main error, as I mentioned before, was unable to put the plate in. I had to use the ball. Additional translation of the observational information into code, as well as initial experimentation. The video may have not been set up for ideal experimental conditions. Furthering this, a more setup condition taking out the effective AC and fans could be used to minimize errors with the drag. Further analysis could be derived from the tracker software in order to better analyze these results. The Glowscript code for this experiment will be in the comments. I appreciate it. Thank you.